Alright, so in this problem we are given a binary tree and our goal is to perform a level order traversal. Now level order traversal means visiting all nodes level by level, starting from the root and moving top down and left to right within each level, right? So let's have a look at an example. So in this binary tree, if you see, the traversal will produce 10, 6, 15 and then 4, 8, 18, right? That means 10 will be in the first level, 6, 15 on the second level, and then 4, 8 and 18 will be at the third level, right? And now you can notice the output, how each list contains only the nodes at the same level, right? So that's the entire problem statement. Now maybe you can just try to think of a solution for this on your own first. And once you're done, you can just come here and check the solution. Now in order to keep a track of all the nodes at the same level and also to build a list of values at each level separately, we will make use of a queue data structure over here, right? And this queue data structure will help us track which nodes belong to the current level and what's coming next, right? So here's the core idea. First, we initialize the queue with the root node, which essentially becomes level 1. Now in each iteration, we check the number of nodes currently in the queue. And this number is essentially the size of the current level, right, that we are going to process. And then we create a temporary list to hold the values of this particular level, right? And then we one by one remove all the elements of the current level, and for each node, after its removal, we add its value to a temporary list that we declared earlier, right? And also we enqueue its left and right children if they exist, because they belong to the next level that has to be processed, right? And once all the nodes at this level are processed, we append the temporary list to our final result list, right? Which we are going to finally return as the output of our function, right? So this way, each level is processed independently and stored in a nested list, preserving the level by level grouping, right? So that's the entire algorithm. Now maybe let's take a sample tree and walk through it step by step, right? So to start with, we just have the root node 10 in our queue, right? So we process it. First we dequeue it, right? And then we add 10 to a new temporary list, right? And then we enqueue its children 6 and 15. And since this is the only node at the current level, so we simply add the level list, which has only 10 right now, to our result, right? Now the queue contains nodes 6 and 15. Now these are the nodes for level 2, right? So we again create a new list for this particular level. First we process 6 and add its children 4 and 8 to the queue and remove 6 from the queue. Then we process 15 and add its right child, which is the only child, 18 to the queue, right? So this level gives us 6, 15, which we add to the result, right? Now in the queue, we have 4, 8 and 18, which are the nodes for level 3, right? And all of them are leaves, as you can see. So now no new children are added, and we just collect their values in the new list for the current level and add it to the result, right? So the traversal is now complete. We have visited the tree level by level and collected values into separate lists, right? Now maybe let's go through the code for this particular solution. So first of all, we begin by importing the deck structure from the Python's collection module, and this gives us an efficient queue in Python, right? Then we define the tree node class representing every node of the tree, which has a val to store the data and the pointers to the left and the right children, right? Now inside the solution class, the method level order takes the root of the tree, right? And inside it, we handle the base case first. If the tree is empty, right, that is the root is none, we just return an empty list, right? Otherwise, we initialize our result list and the queue with the root node. Now we enter the main loop that will run as long as the queue has some nodes, right? Now first, we determine the number of nodes at the current level. Now this is crucial because it separates levels, and it will ensure that we build new list per level using the level nodes list that we are initializing here. Then we iterate level size times to process only the current level nodes, right? So we remove the current node from the queue and then append its value to the level nodes list. And after retrieving the value, we then enqueue the left and the right children of the current node if they exist, right? And now once the level is processed, we append the level nodes list to the result, and this is what gives us the desired nested list format, right? And finally, when all the nodes are processed, we return the result as our final output. So that's the entire solution. Now maybe let's talk about the time and the space complexity for it. So the time complexity over here will be order of n, right? Because we simply visit every node once in the level order traversal. So that's pretty intuitive over here. And the space complexity over here will be order of n, since we are using a queue to store nodes level by level, which can actually grow up to n by 2 nodes at the last level in the worst case, right? So that's the entire solution. I hope you understood it well now, and now I will see you in the next one. Happy coding.